Hello folks and welcome. In this video, we're going to talk about stoichiometry and how you can use it to balance equations of chemical reactions. The reason why I chose stoichiometry to be the topic of this video is that I believe that stoichiometry is a crucial foundation for students to understand the essence of chemistry. Also, more advanced chemistry also requires the patterns and the ideas we obtained from stoichiometry. For example, we must be able to apply stoichiometry when we try to write an equilibrium equation for solutions. Okay, without further ado, let's get started. First, we need to know what stoichiometry means. The word itself sounds complicated, but in fact, it is just like a chem version of 1 plus 1 equals 2. Basically, it is a mathematical representation of the conservation of atoms, mass, and charge. Okay, it might still sound confusing, but let's do an example quickly and you will see how simple the concept really is and how you can apply it. So, let's assume we add some hydrogen peroxide, and with some help from catalyst, we see some gas is produced, and this gas is oxygen, as it can reignite the flamed out stick, and the liquid left inside the bottle is water. So now we have an equation. The reactant, here we have H2O2, and the products are H2O and O2, as you can see here. It looks good, except it does not satisfy 1 plus 1 equals 2. And we see that we have one more oxygen on the product side. But how can we fix that? Well, use stoichiometry. So let's put 1 in front of H2O2. And on the right, we have 1 water, H2O, no problem. But according to the conservation of atoms, we can only have 1 oxygen, 1 O here. So we put 0.5 in front of oxygen, and now we're almost there. In a balanced chemical reaction, we can only have integers as coefficients. So let's multiply both sides by 2. And now we have 2H2O2 produces 2H2O and 1 O2. Perfect. And now the equation is balanced. And that is the basics of stoichiometry. And we just used it to balance a real chemical equation. Awesome. Okay, and finally, you might ask, what does stoichiometry have to do with our life? Why are we learning it? Well, actually stoichiometry is everywhere. For example, the airbags in cars are inflated by the nitrogen gas produced from NaN3 or sodium azide. To figure out how much sodium azide is needed, the engineers have to use stoichiometry to find a relationship between the product, the nitrogen gas, and the reactant, the sodium azide. And by calculating using their molar mass and a balanced equation, they could find the exact amount of sodium azide they need for these life-saving equipment. There are many more examples like this, from toothpaste you use every day, to the rockets that are going to Mars. Stoichiometry is the capstone that helps us build a better world. Thank you for watching this video, and I'll see you next time.